In this video, we're going to talk about the transformation rules and how they apply to functions. So in this chart, I just listed out all the different transformations that can occur, and I kind of grouped them based on their type. So the first two involve introducing a negative into the function. So if the negative's on the outside of the function, so outside of the grouping symbols, whether it be parentheses, the square root sign, absolute value, whatever, that's going to reflect the function over the x-axis. So think about it's going to take the function, it's going to flip it upside down. So essentially every y-coordinate is going to flip its sign. So if it's positive, it's going to become negative, and vice versa. If the negative's on the inside of the function, so underneath the radical sign or inside the parentheses, basically if it's directly in front of the x, what it's going to do is going to reflect your function over the y-axis. So think about in the middle, just taking it and flipping it side to side. So like imagine if the y-axis were a mirror, kind of, you'd have mirror images on the both sides if you reflect it over the y-axis. When you reflect it over the y-axis, every x-coordinate is going to flip its sign. So the next two is when you introduce, you're either adding or subtracting a number on the outside of the function, and that's just going to shift or transform the function either up or down. Notice how with the radical sign for the example, that +2 is outside of that radical sign. So that's what I mean when I say it's outside of the function. And that's going to basically, that's going to affect your y-coordinates. So if it's a +2 or any plus number on the outside, it's going to move the function up. And if it's a minus, it's going to move the function down. And that's going to change the corresponding y-coordinates to either get increased. If it moves up 5, you're going to increase every y-coordinate by 5. If you have a -2, it's going to decrease every y-coordinate by 2. So that's what happens when you have an up and down shift. For left and right, this is when you're adding or subtracting a constant term on the inside of the function. So either inside the parentheses or inside the absolute value, or in this case underneath the radical sign. And this is going to shift your function left and right. So what's interesting about the transformations that occur inside of the parentheses or inside of the function is that they always kind of behave the opposite from how you think that they should. So a +2 on the inside, if you know that the left-right movement is going to happen on the inside, you might think that logically a plus would move it to the right because that's where x is getting more positive. But in fact, actually, it goes the opposite way. So if you have a plus number on the inside with the x, it's going to move it to the left. And if you have a minus on the inside, it's going to move it to the right. So that's just going to either increase or decrease your x-coordinates by the appropriate amount. So that's all of your shifting. So left, right, up, and down. And then we have stretches. We have two different kinds of stretches. We have vertical stretches and shrinks, and we have horizontal stretches and shrinks. So the first kind are going to be your vertical stretching and shrinking. This is going to be when you have a number on the outside of the function and you're multiplying it in. So for example, this 2 square root of x, that 2 is a number on the outside getting multiplied in. And that's going to take the function and kind of imagine someone, if they held on to the top and bottom of the function, if they kind of pulled it up or stretched it up. So essentially it's going to make your function taller and skinnier. So that's going to be a number on the outside, and that's going to happen when that number that's getting multiplied in is greater than 1. For the second one, a vertical shrink, imagine someone, if they had like the top and the bottom of the function in a vise, for example, and they were to kind of smush it down, it's going to make the graph look a little bit shorter and wider. So vertical shrink is going to take the function, and if you have a number on the outside multiplying it in, that's going to happen when that number on the outside is in between 0 and 1. Now notice for these it says the absolute value of c. We only really care about the positive of this because if it's a negative on the outside, a negative is going to reflect it. It's not going to impact the vertical stretch or shrink. So think of just looking at the number, the negative does something different, the negative is going to reflect it, and just kind of focus on the number and decide whether it's going to be a stretch or a shrink. So if it's bigger than 1, it stretches it. If it's smaller than 1, it's going to shrink it. And the last two kinds of transformations we're going to talk about are horizontal stretching and shrinking. So again, for horizontal stretching and stretching and shrinking, think of someone kind of taking the sides of a function and either pulling it out like an accordion or pushing it back in like an accordion. So if you pulled the function out, that would be a horizontal stretch. So imagine an accordion kind of pulling out. It's going to get wider, it's going to get a little bit shorter, and it's going to appear to get a little bit shorter. And a horizontal shrink, imagine someone kind of pushing an accordion in, or if you take the sides of a graph and kind of push it in like a vise, is going to make the graph appear to be taller and skinnier. So these numbers are going to occur on the inside of the function. So, and again, anything that happens on the inside of the function kind of behaves the opposite from how you think it would. So for the first example, if we have a number that's greater than 1 inside the function, so the example is square root of 2x. That 2 is actually going to be a shrink. So the trick for these ones that I like to think of is take that number that's inside and right in front of x, take the reciprocal first, so flip it, and then it's going to follow the exact same rules as the vertical stretching and shrinking. So that 2, when you take the reciprocal, would be 1/2, so that would be a horizontal shrink by a half. So imagine someone on the outside kind of taking that graph, pushing it in half its original width, so that would be a horizontal shrink. So essentially any number that's greater than 1, if you take its reciprocal, will give you then a horizontal shrink. And then finally, the horizontal stretch, that's going to be a number that's less than 1, in between 0 and 1 inside the parentheses with the x. So again, take its reciprocal, and that's going to be a horizontal stretch. So again, imagine someone on the outsides of the function, on the left and right, kind of pulling it out. There's a couple patterns in this chart that might be helpful to notice, and it deals with whether the transformation's on the inside of the function or if it's on the outside of the function. So I'm going to kind of highlight those for you so you can see the difference. So if you notice, if we start at the top, that negative's on the outside of the function, so I'm going to go ahead and highlight that. I'm looking for anything that's happening on the outside, so here, +2, -2, down with the stretching and shrinking, I'm looking for numbers that are on the outside, so that vertical stretch and vertical shrink. And then if I go back, everything else that's left should be a horizontal, or should be on the inside of the function, so reflect over y, left C, right C, horizontal shrink, and finally horizontal stretch. Okay, so the significance of these are that, so anything that happens on the outside of the function is going to be some sort of vertical movement, so it's going to impact your y coordinate. So reflect over the x-axis, takes the function, flips it upside down, and if you imagine a reflection over x, that's a vertical movement. It's taking it, flipping it upside down, that's happening vertically. If you look at the up and down, again, it's a vertical movement, and it's impacting your y coordinate. So it's either going to take y and either add or subtract a number to every coordinate, and that's how it's going to shift it up or down. And last, for the verticals, you have the vertical stretching and shrinking. So if you have a number on the outside like a 2, what it's going to do is going to take every single y coordinate and only the y coordinate, and it's going to multiply it by 2. So every y is going to get that much bigger. And then what's left, all the horizontal ones, same idea, but these are with your x. So for the reflect over the y-axis, it's a horizontal movement, so it's going to impact what happens to your x-coordinate. So think, if you take something and reflect it over the y-axis, every x-coordinate is going to change its sign. It's going to become the opposite. If you move left and right, it's another horizontal movement, so it's shifting the graph left and right, and the coordinate that's affected when you move left and right is your x-axis, or your x-coordinate. And then last but not least, your horizontal stretch and shrink. Again, obviously it's called horizontal, so it's going to affect your x-coordinate. But imagine, like, if you have a horizontal shrink by a half, it's going to take every original x-coordinate and divide it in half. So imagine a horizontal shrink is that person standing on the outside kind of pushing the graph in. If you shrink it by a half, you're going to push it in half to its original size. So it would make sense that every x-coordinate would then divide by 2. So there's just a general overview of all of the transformations. In the next video I'll show you a couple examples on how to graph these, how to identify the functions, and there'll be a video later on too for another kind of example with the transformations.